New nanotechnology will empower a solid, electric flow creation inside the human body. Nanowork News. Another nanotechnology improvement by a global exploration group drove by Tel Aviv University analysts will make it conceivable to produce electric flows and voltage inside the human body through the initiation of different organs, mechanical power. The specialists clarify that the advancement includes another and exceptionally solid organic material, like collagen, which is non-poisonous and makes no mischief to the body's tissues. The analysts accept that this new nanotechnology has numerous possible applications in medication, including reaping clean energy to work gadgets embedded in the body, like pacemakers, through the body's regular developments, wiping out the requirement for batteries. The examination was driven by Professor Ehud Gazet of the Shmonis School of Biomedicine and Cancer Research at the Wise Faculty of Life Sciences, the Department of Materials Science and Engineering at the Fleischmann Faculty of Engineering and the Center for Nanoscience and Nanotechnology, alongside his lab group, Dr. Santu Bera and Dr. Wei Ji. Additionally, participating in the examination were scientists from the Weizmann Institute and various exploration establishments in Ireland, China and Australia. Because of their discoveries, the specialists got 2 ERC-POC awards pointed toward utilizing the logical exploration from the ERC award that Gazet had recently won for applied innovation. The exploration was distributed in the renowned diary Nature Communications, Molecular Designing of Piezoelectricity and Collagen Impersonating Peptide Gatherings. Professor Gazet, who is likewise founding director of the Blavatnik Center for Drug Discovery, clarifies. Collagen is the most predominant protein in the human body, establishing about 30% of the entirety of the proteins in our body. It is an organic material with a helical design and an assortment of significant actual properties, like mechanical strength and adaptability, which are valuable in numerous applications. Notwithstanding, in light of the fact that the collagen atom itself is enormous and complex, specialists have for quite some time been searching for a moderate, short and basic particle that depends on collagen and shows comparative properties. About 18 months prior, in the diary Nature Materials, rigid helical-like gatherings from a self-collecting tripeptide are gathering distributed an investigation in which we utilized nanotechnological intends to design another organic material that meets these necessities. It is a tripeptide, an exceptionally short particle called Hype-Phi comprising of just 3 amino acids, equipped for a straightforward cycle of self-get-together of shaping a collagen-like helical design that is adaptable and flaunts a strength like that of the metal titanium. In the current investigation, we look to analyze whether the new material we created bears another element that portrays collagen, piezoelectricity. Piezoelectricity is the capacity of a material to produce electric flows and voltage because of the utilization of mechanical power, or the other way around, to make a mechanical power as the consequence of openness to an electric field. In the examination, the specialists made nanometric constructions of the designed material, and with the assistance of cutting-edge nanotechnology devices, applied mechanical tension on them. The test uncovered that the material does to be sure create electric flows and voltage because of the pressing factor. Additionally, minuscule constructions of just many nanometers showed perhaps the most significant level of piezoelectric capacity at any point found, practically identical or better than that of the piezoelectric materials normally found in the present market, the greater part of which contain lead and are subsequently not reasonable for clinical applications. As indicated by the specialists, the disclosure of piezoelectricity of this extent in a nanometric material is of extraordinary importance, as it exhibits the capacity of the designed material to fill in as a sort of minuscule engine for exceptionally little gadgets. Then, the scientists intend to apply crystallography and computational quantum mechanical techniques, thickness utilitarian hypothesis, to acquire an inside and out comprehension of the material's piezoelectric conduct and in this manner empower the precise designing of gems for the structure of biomedical gadgets. Professor Gazet adds, the majority of the piezoelectric materials that we are aware of today are harmful toxic materials, or polymers, which means they are not earth and human body accommodating. Our new material, notwithstanding, is totally organic, and consequently reasonable for utilizes inside the body. For instance, a gadget produced using this material may supplant a battery that provisions energy to inserts like pacemakers, however it ought to be supplanted occasionally. Body developments, like pulses, jaw developments, solid discharges, or whatever other development that happens in the body consistently, will accuse the gadget of power, which will ceaselessly initiate the embed. Presently, as a feature of their proceeding with research, the specialists are looking to comprehend the atomic systems of the designed material, fully intent on understanding its huge potential and transforming this logical revelation into applied innovation. At this stage, the attention is on the advancement of clinical gadgets, yet Professor Gazet underscores that, harmless to the ecosystem piezoelectric materials, for example, the one we have created, have enormous potential in a wide scope of regions since they produce environmentally friendly power energy utilizing mechanical power that is being utilized in any case. For instance, a vehicle driving down the road can turn on the street lamps. These materials may likewise supplant lead-containing piezoelectric materials that are as of now in broad use, yet that raise worries about the spillage of harmful metal into the climate.